Welcome to part 5 of Mathematics exam series for Victoria, Australia. In this video, we will solve a 2020 trial exam 1 paper, questions from 8 to 9. Hello Math Champions, I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything. This is the third part of a 2020 trial exam paper for mathematics in Victoria, Australia. And this is a technology-free paper. Two tailors, A and B, in a bank serve customers. One day, the proportion of 4 random customers in the queue served by tailor A waiting longer than 5 minutes is 0.36, and the proportion of 144 random customers in the queue served by tailor B waiting longer than 5 minutes is 0.64. Assume both queues have the same length when a customer enters the bank. Now, question 1. Which queue should a customer choose if he knows these statistics? Explain by quoting the 95% confidence interval. Question 2. The probabilities that a customer going to tailor A and B are half and 1/3 respectively, and the probability of not doing banking on the day after entering the bank due to long queues is 1/6. Using 0.36 for A and 0.64 for B as point estimates, determine the probability that a customer spends more than 5 minutes in waiting. This question is a question regarding the sampling and the population proportion. As for the question 1, based on the given sampling proportion of both tailors A and B, we need to work out the population proportion with 95% confidence interval for both tailors A and B for taking more than 5 minutes to serve a customer. Hence, we are able to determine which tailor a customer should choose to go with. First, we need to calculate the standard deviations of both tailors for taking more than 5 minutes to serve a customer. Since the samples are taken from a large population, then the distribution can be regarded as a binomial distribution. Therefore, the standard deviations for both tailors can be calculated using the binomial distribution formula. After calculating the standard deviation of these sample proportions for both A and B, the 95% confidence interval for both tailors can be estimated by interval estimation formula. As for tailor A, the interval is from 0 to 0.83, while for tailor B, the interval is from 0.56 to 0.72. So, it is better choosing tailor A. For question 2, the probability that a customer spends more than 5 minutes in waiting can be calculated by the probability that a customer spends more than 5 minutes in waiting for tailor A, given A has been already chosen, times the probability tailor A is chosen, plus the probability that a customer spends more than 5 minutes in waiting for tailor B, given that B has been already chosen, times the probability tailor B is chosen. Hence, the result of spending more than 5 minutes in waiting is 0.4. Question 9 is the last question for this paper. It is a function of x with fractional index. The numerator is an even number, while the denominator is an odd number. In this fashion, the domain of the function is entire real number, while the range of the function is y greater than 0. The first question is asking to prove the inequality when x is between -1 and +1 except that x equals 0. The second question asks us to express the area bounded by two functions with different fractional index and hence show the value of the area when n approaches to infinite. Now, according to the given information that m and n plus 2 are positive integers and n and n plus 2 are positive odd integers, then 2n plus mn is greater than 2n plus mn. After both sides of the inequality being divided by the same positive integer n times the sum of n plus 2, we find that m over n is greater than the sum of n plus 2 over the sum of n plus 2. Since both functions are even functions, they are symmetric to the y-axis, so we focus on the domain of between 0 and 1. As we know, when the base is between 0 and 1, the function is a monotonic decreasing function. Therefore, x to the power of the sum of n plus 2 over the sum of n plus 2 is greater than x to the power of m over n when x is between -1 and a +1 except the point of 0. Since the function is a symmetric function, the bounded area can be expressed by 2 times the definite integral of the difference of the two functions from 0 to 1. Here we have a diagram to illustrate the curve of the difference of the two functions when m takes 4 and n takes 3. After being simplified, the bounded area equals 4 times the value of m minus n over the product of the sum of m plus n plus 4 and the sum of m plus n. Since m is greater than n, which also greater than 0, we may apply the scaling method to the second part of question 2. So the value of m minus n over the sum of m plus n is less than the sum of m plus n over itself, which actually is 1. From the result of the first part of this question, the area is greater than 0, and at the same time, the area is less than 4 over the sum of m plus n plus 4. Obviously, when n approaches to infinite, the expression of 4 over the sum of m plus n plus 4 also approaches to 0. Therefore, according to the squeeze theorem, when n approaches to infinite, the bounded area A is 0. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.